the point here is that, be careful. Be careful when you interpret the data in these tests to ensure that the tests were done well, because they're not done that well all the time in the field. Sometimes, like I've plotted this very kind of smooth curve in the previous plots. I mean, a lot of times, it's really just maybe 6 or 7 points. Well, a lot can happen in between those 6 or 7 distinct points, especially, and then other times the pressures. Remember, the pressures are measured, I guess I should have mentioned, in all cases that all these plots we've talked about, the pressures we're talking about are measured at the surface. So you have to add in, to get the principal stress correct, you have to add in the head pressure associated with the column of water that's in the well, right? Or the column of fluid, not just water, but column of fluid that's in the well. So you have to add in that head pressure. And, a lot of times when these tests are done, these pressure measurements, I mean, in the most crude way, can be read off a gauge, that's bouncing around at the surface, right? So while we plot these really smooth curves, in reality, keep in mind that a lot of these tests can be done with literally someone standing there watching a pressure gauge bounce around, and at 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 minutes, writing down the pressure. Well, that's obviously not the best way to do it. If you have actual downhole measurements, some logging system in the bottom hole assembly, then you're going to get much more accurate readings. Right? So be careful. And the reason is, particularly if you're leading up to wanting to do some stimulation with hydraulic fracturing, it's important that you don't mistake. So what I say here is when the minimum principal stress is close to the vertical stress, make sure you take great care in interpreting your data and integrate your density logs. So we typically just compute the vertical stress, from a guesstimate, right? Or use 1 psi per foot, right? But if your guesstimate is on the order of what you're seeing in your mini frac tests, then it's important to look into it in more detail, because what this will mean in a stimulation event, it could mean the difference in your fractures growing horizontally or growing vertically, right? If your minimum stress, your minimum principal stress is the vertical stress, then your fractures are going to initiate at the wellbore, at the top and bottom, but then they're going to turn and they're going to grow horizontally. They're going to initiate at the top and the bottom because of the stress concentrations, but they're going to turn and they're going to grow in a plane that's parallel to the surface of the earth, right? Which could or could not be desirable. But it's just important that you understand that. So this plot actually shows that. This is the white the white values are several S3 measurements from leak-off tests, and one thing to notice is that they are pretty consistent. So if you look up here in this region, they're not wildly scattered. They're pretty consistent, and so you can have some confidence that these are a pretty real evaluation of the minimum principal stress, and they're very, very close to the vertical stress as measured from the actual density log. So not just 1 psi per foot or just a guess, right? And you can tell that because it's not just a straight line; it's a curve. So these were integrated from the density logs, and in this case, they're very close to one another. So it's very important to in this scenario to watch out.